or the better utilization of the resources, and the resources can be scalable, and there may be the more flexibility. So optimization of the infrastructure, ultimately what we are getting, optimized infrastructure, reduce cost and improved agility. Traditional virtualization, we know this thing like server virtualization, storage virtualization, and network virtualization. Okay, so these three things are there. Storage, this we'll try to understand one by one. First, let us start with the server virtualization. So server means again the uh, a server will have the single server will act as many, right? So here you can see the create virtual instances of the physical server, allowing multiple virtual machines to run on the single physical server. So physical servers is one, but it is divided among multiple virtual server. So hypervisor is a, you can say, the tool or the main enabler which can partition the physical server into multiple servers, like multiple resources. I mean, or for any resources it is valid. That hypervisor is the intermediate plays an intermediary role to partition the resources logically. So again, the benefit is same: the improved resource utilization, cost reduction, and scalability. Now coming to the storage virtualization, it is again the whenever you are using some storage space, right, and you are paying certain amount to some cloud service provider, you don't know from where the storage is coming, but it is managed, it is given to you as per your requirement. Only you are paying the money, right? So like it is you are becoming abstracted about the storage space. Okay, so that's why you see the abstract the storage resources from the physical hardware and create a logical layer that enables the centralized management and utilization of the storage assets. Now pooling of the storage resources from multiple devices and presenting them as a single virtualized. So it is essentially it is getting the resources from multiple devices, and it is logically combined together to form it one. Okay, so you will find or you will get an essence that the entire storage space is given for you. Now uh, this benefit is again simplified management, improved performance, and this seamless data migration. Coming to the network virtualization, so network virtualization is again there are different devices in the network, right? Like switch, router, then your firewall is there. So all of these devices, those can also be virtualized. Okay, that means through network virtualization it creates an virtual environment, so that the this switches, router, those can be logically like divided among multiple applications or multiple users. So uh, for that this you see the enabler in creating the virtual network that operate independently. That means those are, you are logically it is dividing, but those will have the capability to handle the network stuff independently. So automatically there will be increase in flexibility, and those devices, these logically separated devices will be different from one another. So benefit of the this network virtualization is simplified network management, improved security, and increased agility in deploying and managing the network services. A few use cases of the these virtualizations are like many other can be there. Okay, so we'll be focusing to the cloud computing that we'll be discussing, but before that, data center consolidation, okay, then disaster recovery. So we'll discuss about this. Let us say data center consolidation, how it works, and what is the importance, let us discuss. So migration of the physical server and resources into virtual environment. So try to understand this thing. This is the migration of the physical server and resource into virtualized environment. So that means you need a server, right? So you are working in an organization, and you want to you want to this use multiple instances of a server, because your requirement may be, in the organization there may be different sections, different departments. So in the department in different departments there may be different requirements. So whether if you have the single server, you can virtualize it in order to provide the services to all of them, right? So this is very important, you can say, the use case that we typically we use in different organizations. So which reduce the number of the physical servers. That is obvious if you are breaking it down into multiple part logically, so that can be useful. So efficient organization to concentrate workload onto fewer physical server, leading to cost saving in terms of hardware, power, and cooling. Okay, because if you are procuring the different server for different departments in the organization, so it is very you should have the hardware, power, and cooling. All of these things will be required, right? Instead of that, the same server, if it is possible, if it is capable enough, we can divide it into multiple part logically. So again, the benefit is the same: increased efficiency, simplified management, and improved scalability. Coming to the disaster recovery. Now, disaster recovery is efficient replication of the virtualized environment in the disaster management. Okay, so there may be disaster, can be anything, any environmental disaster there also, or you are using some you are using some applications, right? So maybe one server, all the data are there. Okay, so if you are dependent on that single point, it can fail also. So at that time, what you will do? So for that, this virtualization concept, the same server can be the same resources can be divided into multiple, in order to have the multiple instances of the resources. It can be the whenever we are talking about the disaster recovery, we can have the different uh, infrastructure logically, so that when it fails, you can have it from the alternate one. And it is if you have those mechanisms, it is very easy to migrate from the older one to the newer one, and it can you can activate based on your requirement. Now coming to the cloud computing, right? This is very we use this cloud computing concept in our day-to-day life. So it is again, it provides some on-demand computing resources, right? So on-demand computing resources. So advantages are the same as elasticity, that is scaling up or scaling down, pay per use model. It follows user needs to pay a certain amount based on their utilization of the resources. Then self-service, that is resource can be accessed by itself. You can use the resources at any point of time, and from any corner of the world. So the typical services, you can say, comes under this cloud computing is the software as a service, platform as a service, and infrastructure as a service. So this as a service is very common nowadays. This as a service is very common nowadays, and this is somehow you can find in it will be dependent on any as a service or X as a service. It is dependent on the concept of virtualization. That means you have the very limited resource, but you are providing the services to the multiple applications. Okay, so few common example you can see: the healthcare as a service. You will find many research papers also. Transportation as a services, communication as a, and many others you will find. Okay, so transportation as a service. If you say that any cab, okay, like Ola cab, you are getting Ola or Uber cab. If you are getting, so you know the same cab is used for multiple users, right? You can see it from that direction. That same cab is used for multiple users. Only you are paying the rent. Okay, so the features are very I mean, these features are there. That's why it is becoming more and more popular. The features like limited physical intervention by the users, cost effectiveness, remote access, and scalability. So few challenges are there: performance overhead, security concern, and licensing implications. So performance overhead is like it is very like crucial to like consider this performance overhead. Okay, so whenever we are sharing the resources, right, single resources shared among multiple applications, right? So you have to be very careful that the based on the capabilities of this resource of these resources, based on the capability, you have to divide it logically so that the performance would not be hampered, right? Let us say server is there and you are dividing it into 50 for 50 server, or you are making the instances of 50 server, so it may not work perfectly. Rather, it can work efficiently if you will have at most 10. Okay, so that is a overhead that you have to be very concerned. So impact of the, again, the if the performance of the this overhead will be there, automatically there will be some problem in the workload of the whatever application you are working on that. Okay, so migration strategies include optimizing resource allocation, utilizing hardware assisted virtualization technology, and implementing the performance monitoring and tuning. Now, licensing implications, again, whenever you are talking about this virtualization, so multiple softwares maybe you are using, right? Or applications you are using. So, those applications whenever you are creating the virtual environment, it may be at multiple times you are doing it. Mm. And as you are doing it for multiple times, so it is very multiple uh, instances are there for your VM, for your virtual machines, right? So it you may have the different type of software on those virtual machines. So in a if you are procuring a software, you don't know for how many instances you can create, or the maintaining the timeline of the, because all of these software are like installed in those virtual machines, not, it may not be simultaneously, right? So these issues will come. So the organization need to be careful to understand or know about the proper licensing features. Now, coming to the sensor cloud or sensors as a service, this is a special type of. I'm going into the like now I'm going into the IoT part. So, sensor cloud is a special type of virtualized environment, right? So, which virtualize the sensors, like sensor services. The same sensor can be useful for multiple applications. So, if you want to understand this sensor as a service, anyways, I will be describing it, and I will not focused on discussing the complex mathematical part, but rather I would like to discuss with you the main concept, major concept, right? and the corresponding issues in sensor cloud. Before going into sensor cloud, let us understand that what is a sensor network in very brief. Okay, so sensor network, we know it is very popular for the last few decades. So different physical sensor nodes are deployed, let us say, in different areas. Okay, and these sensor nodes, it will have the like three main part or main component. One is sensing unit, then processing unit, and communication unit. So role of these sensor nodes are it can sense its surroundings. Okay, sense its surrounding means it is measuring some parameters. It can be temperature, it can be humidity. Okay, then transmit the sense data to a centralized entity or the maybe the next node based on the requirement. So whenever it is transmitting the data, it can transmit through single hop connectivity or through multi hop connectivity. So here you can see this node is connected to the sink. Sink is the like centralized entity, a special type of you can say the node. So whenever it is transmitting directly, that is the single hop connectivity. But whenever this node is wants to transmit, it has to either go like this and this, or this and this. So it has to traverse through multiple nodes, right? So multi-hop connectivity will be there. Now, this nodes, this is very popular. It can sense the its surrounding and transmit the data to the sink, and based on that, it can work. Now, for different applications, you can use this wireless sensor network, target tracking, wildlife monitoring, healthcare, industries, applications, smart home, agriculture, and so on. Now, there are few limitations that we identified in the traditional wireless network, wireless sensor network. So, is that let us try to understand this with some examples, right? For example, I am a farmer and I'm from the non-technical background. I don't know about the sensor, hardware, all these things. I'm not aware of that, right? So if I am a farmer and I want to uh, make my field or the like agricultural field very smart, so I want to put some sensors over there in order to measure different in order to measure different parameters, such as I mentioned, the temperature of the field, or the crop condition, or the water level, soil moisture, these things. So for that, I may need to have different sensors. But whenever I am using this wireless sensor network, I don't know from whom to procure those sensors, right? And whether I am procuring those sensors correctly or not, whether these sensors are useful or not, then who are the right vendors, because in the market there are maybe many companies who are providing these type of sensors. Okay, whether I am paying the correct price or not, so those things will be an issue as a normal person. Now, this thing, let us say my friend is there, he is very he's a technical person, and I can, with his help, I can procure those sensor node. But what about the deployment? I don't know again the deployment, how to deploy the sensor node and how to connect with multiple nodes with one another. Okay, so these are the like it's a really an issue for me. Again, with someone help, I can deploy the sensor node, so that the minimum number of sensor can cover the maximum area of the node. So for that, maybe my friend is doing some like helping me to do so. Okay. After the, let us say, my procurement is done, deployment is done, then what about the maintenance? After that, I have to know that how it is working, how to get data, whether some fault in the hardware or software is there or not, or how to change the battery of those nodes, because those nodes are typically battery powered, right? So these issues will be there. So if for a single application, for me, if I will go through it, I have to, for using this traditional wireless sensor network, I have to go through all these problems. On the other hand, if tomorrow I wish to I wish to my agricultural season is over and I want to make my home smarter. So that for that also I need a set of sensor, or you can say the I need a sensor network. For that, this sensor I cannot simply pull out the sensor node from the agricultural field and I can put it in the smart home. That is not possible because those sensors are significantly different, which will be used for the smart home. Then again I have to go through the this procurement, deployment, maintenance, all these things. So it is a very difficult for the normal user to have this sort of mechanism to procuring the wireless sensor. Now, in order to encounter this particular problem, this particular issue, we uh, started working on sensors as a service, or you can say the virtualized sensor node for IoT, virtualization of the sensors for IoT applications. So traditionally, this whole thing is known as sensor cloud. Okay. Now, sensor cloud, whenever we are mentioning this term, it is not just simple integration of sensor and cloud, or it is not like dumping the data from the sensor to the cloud. Now, in trying to make you understand that how it is related to IoT, or how it is useful for IoT. So, whenever we are talking about IoT, you know the sensors are very important part because it can sense, and based on the sense information, the IoT system will be reacting. So those sensors are very intrinsic part of the IoT, any IoT platform, and which can serve multiple applications. So whenever we are talking about the sensor in IoT, so as a single sensor may be useful for multiple applications, but for that it is not so easy. You in that way you want to increase the utilization of the sensors, but practically if you think it's very difficult. You don't know how to use this particular sensor for multiple applications. So the concept of virtualization is coming into the picture, and through the virtualization the single sensor node can be useful for multiple applications. So the limitation of single user centricity of the traditional sensor network that is addressed by the evolution of the sensor cloud, or you can say the virtualization of the sensor. So here, unlike our previous example, we have seen that we have to, as an end user, you have to procure the sensor, you have to maintain the sensor, and you have to deploy the sensor. Of these things you have to do. But in case of sensor cloud, you are not doing this thing. Only you are paying money to the end user, to the service provider, and you are getting the services very similar to your electricity or your gas, LPG, and your water. You are based on your consumption, you are paying the amount. So through the concept of sensor cloud or virtualizing the sensor node, you will find that in the this is the traditional approach. Traditional approach, you will find that this sensor network is useful for single user, but through the virtualization concept, we are enabling it. All we are enabling a sensor network maybe, or a particular sensor node for multiple applications. Now, this sensor cloud, this is it is a service oriented architecture model, you can say. And here you can see the sensor owners are there, SCSPs are there, and end users are there, right? So end user here in this figure, you can see they are just registering with the system, getting the services, and they are paying certain amount. On the other hand, sensor owners, they deploy the sensor nodes over different geographical locations, and based on the utilizations of these sensors for different applications, these nodes, based on the applications of these sensors, these owners, they are getting the services, right? Now, SCSP is another person who is very similar to cloud service provider in the traditional cloud, who is enabling the services, who is managing the entire architecture. But yes, for this SCSP is using certain algorithm for doing so. Like, for example, the pricing, he or she is doing, then virtual sensor formation, these things are doing. I'm coming to that in brief also. So if you see the sensor cloud, this is the organizational view of the sensor cloud. Here you can see the like users are like from organization. It is pretty simple that it is, you have some list of services, you are selecting one and you are getting the services, you are paying the money, only that one. But in the real view, it is much complex, because you have to concern about the internal uh, issues like sensor scheduling, scaling up, scaling down, then data storage, and specialized processing, energy management, QoS, all these different things will be there. So in more details, if you want to go with the sensor cloud, I explained the main key points. But if you want to go with the other thing with the more details, so you can dig into these papers. So there are, as in the normal virtualization also we have seen, in traditional virtualization, it is not so easy. You have to, you should have different issues. So similar to the traditional virtualization, in sensor virtualization also, a there will be different management issues. So I'll be not again going to the mathematical model in details, but I will be overall idea I'll be giving, but try to understand the from the problem point of view. So first is the virtual sensor formation, then data caching and pricing. Virtual sensor formation, it is very similar to your VM formation in the traditional cloud. So why we are doing this? Because the resources, that is the essentially the like battery energy of the node, that is very limited in case of sensor node. So all of a sudden it may be like the sensor, the battery of a sensor node may be drain out after certain number or certain amount of time it is giving service, right? So may- at that time, what should we do? How to replace a sensor node? Okay, for that, this virtualization is very much, virtualization of the sensor node is very much important, or forming the virtual sensor node is very much important. Now, optimal virtual sensor is coming into the picture. Why it is required? Because we may have multiple options to select a sensor for serving certain applications, but what are those like what are those services like this how to select those sensor nodes based on the availability of the sensor nodes, based on their health, based on the requirement of the applications. So for considering this, by considering this optimal composition in a virtual sensor is very much important. So if you see in this figure, these are the application areas. So these are distinct from one another. There is no overlapping region, right? So the similar type of sensors, those are forming a single virtual sensors. Like is red color, you can see this VS1, then yellow color, they are forming VS2, VS3 is this blue color is forming VS3, and all together they are forming the virtual sensor group. Okay, again these are the logical representation, and but these are saying that the overlapping area of the sensor uh, deployment of the sensor region, that is overlapping, but practically it may not be overlapping. I mean it should be overlapping. This is non-overlapping. Okay, you can see the application area non-overlapping, but practically it can be overlapping because see, as I mentioned that this is based on the service oriented architecture and there is some monetary transaction are involved, right? Like there means the sensor owners, they are making some profit out of the usage of the sensor of their respective sensor nodes. Okay, for that, uh, so as a sensor owner, when they when they in getting into the sensor cloud architecture or virtualized sensor this platform, so they will try to deploy the sensor node in that region from where you I mean from where the possibilities of the getting the more revenue is there. That means very you can bring an analogy, like let us say our a tea shop. Okay, the person wish to put his stall in a location from where he can create more and more sale, right? Like so that the profit can be increased. Okay, but uh, in that way, like same thing will be done by the another let us say another tea seller, right? So same way, the sensor owner, multiple sensor owner, they will think like that, that why there is a restriction in deploying area. So they wish to they may have some wish to deploy the sensor node in any location as per his or her wish. So automatically there will be a situation when the sensor this deployment region will be overlapping. But from the sensor cloud service point service provider point of view, the we should give the opportunity, equal opportunity to all the sensor owner to have to have the business equally, right? So for that, this overlapping area it's required to be considered, and how many times these sensor owners are getting chance for providing service, that is also important. So for that we model this thing mathematically. We are considering different state notation including residual energy, then your some reputation we are calculating. Okay, that is the reputation rating. For that, we use that beta reputation model where using this equation. So we have done this degree of satisfaction and degree of dissatisfaction. You can find it. Finally, we are forming an optimization function using KKT condition. This we have solved Lagrangian multiplier and KKT condition we used. And these are few results. So result is ultimately it is saying this result is saying that they are like equal. I mean all the sensor owners or the sensor nodes. You can see this they are getting almost the equal opportunity. Okay, so you can go through this paper for detailed understanding or more mathematical understanding of the this particular work. Then data caching is another important aspect. So caching we use, you know, in operating system we have gone through that caching. Why we use caching? Because there may be the frequently used information we may keep in the cache. That means the information is required multiple times, and or maybe in the near future we may need it. So we can use the caching mechanism. Okay, so here also we can see the caching mechanism because the as we know this in the sensor cloud, this physical sensor nodes those are consuming certain energy in sensing and transmitting the data. Correct? Sensing and transmitting the data. So for that, this continuously sensing and transmitting the data may not be an efficient way when the change of the environment, change of the this parameter value is not so frequent. For example, this temperature you it may not change after 2 minutes or 5 minutes. So there is no point of sensing again and again of a particular region and transmit the data. So for that, we can have the caching mechanism. So uh, that means the overall idea is due to the slow change in the environment, the same data of the physical sensor node is unaltered, and in such situation, the caching is required to conserve some energy. That means energy should be utilized properly. So this is initially proposed. This is the traditional existing architecture of the cloud, and resource pooling is there. Then caching is there. From this, after that, this cache enabled architecture where it was introduced, this internal cache and external cache for sensor cloud. Considering the reutilization of the sensor data, okay, and the destruction of, or you can say the virtual machine is whenever it is destroyed, the data with the virtual machine is already like it is becoming scrap, right? So for but at the later instant of time, you may need to have this caching mechanism. You may need to have this caching mechanism again to or you may need to have the same data again. For that, you can use this caching mechanism. So here we have done that. We have proposed a new caching mechanism which is known as spatial dynamic cache, which is very much useful for getting the data from a destroyed virtual machine. So spatial dynamic cache in it is like divided into two part. One is reserve, another one is active part. And you can see the part we have like there are two parts. I am coming to that. What is there in reserve part and uh, this active part. So here before that there are two tuples. You can see this ID and T. So here T is the type of the sensor. There may be multiple sensor, right? Type of the sensor data, and ID again there will be this ID. There will be data and time. That means this is the sensor type from that sensor which data I am getting, and the time of the from where we are acquiring the data. So HDC-A contains, that is the active part, it contains the data of the VM which is currently in use, and whether there is this HDC-R, that is the reserve part, is containing the data which is destroyed. And we are assuming the total amount of the memory is, it is M. Okay. So size of HDC-A in an HDC requires to be maximized, because active part we have to give importance to the active part only. So for that again we design some mathematical model and functions in order to address these issues of like maximizing this active part. So we define different parameters, and through this maximization problem, we tried to solve it with certain number of constraints that is mentioned over here. I'm not going into details again. So how it is responding, you try to understand. So responding to the user request, let us go through it step by step. On receiving the request through a web portal from the end user, our system first searches for the data progressively in IC, that is internal cache. You go to the figure again, IC. Okay, IC is here. Then EC is outside near to the resources. Okay, and HDC is again here inside. So first searches at the progressively IC, HDCA, and EC. So first is searching is IC, then in HDCA, then in EC, that is external cache. Whenever a hit is encountered, the data are written. On failing to find the data in the EC, it resends the data from the sensor network and cache into HDC. On the other hand, or for a destroyed virtual machine, how to get it? When a VM is destroyed from the cloud, the system check if the VS caches related to the VM are associated with any other VM. Otherwise, at this instant, the VS cache is moved to HTC R. So these are again few like results which you can see that the caching whenever we are using this spatial dynamic cache, it is there are less amount of miss because we are keeping it. It is obvious also because we are introducing this new cache, that is the spatial dynamic cache. You can go into the this paper for understanding the caching. So finally is the pricing. I would like to discuss with you. Pricing is very much important because whenever as a service provider you cannot charge any random amount from the users, right? So, and also the user cannot say that I will give you 1 rupees for 5 days services. Okay, so there should be some optimization between them. For that, focusing on that, the work has been proposed like maximizing the profit by made by SCSP for this optimal pricing, right? Then optimal pricing to the end users, then end user satisfaction is considered. So basically two prices are considered. One is prices for the hardware and for the infrastructure. Now in this work we consider a very special, because this pricing is important, that we are sure, right? But there may be some special cases. There may be the malfunctioning, or you can say the misbehaving node. So misbehavior can be selfish node, maybe a faulty node, maybe a dead node. So these things are like selfish node is an intentional behavior, and there is some intention to not transmitting the data from one to another. Whereas in the dead node or the faulty node, those are the permanent behavior. It may not wake up. So these are the permanent behavior, you can say. But here we introduce a new behavior that is known as dumb behavior, where is the condition of the dumb behavior is that a sensor node which is unable to communicate to its neighbor node in the presence of adverse environmental effect such as your heavy rainfall, high temperature. Okay, so it is unable to transmit the data, but with the favorable environmental condition it can again transmit the data and it can resume its normal operation. So these nodes, this behavior is not intentional, it is completely unintentional and temporary in nature. So permanent removal of that node is also not a good idea, because those are if you replace that node with another node, that also do the same thing. It is dependent on the environment. For that, we explore the this work that from this node always the sensor these users, they are not getting benefited. On the other hand, the sensor owner, uh, they may not replace those node, right? So there, at the same time, the we should not charge the equal amount that we are charging from a for a normal node from the end users, right? We cannot charge that because this is not always providing the services. In order to handle this issue, we work on this particular work, and here also we consider the reputation of the physical sensor node, and we find the fitness value also based on the uh, performance of a node and how much time it was done in the last few instances. Then here it is, we have used some exponential moving average, and finally we use the reputation, and further we calculate the like fitness of the neighbor node to whom I can transfer the data, and we define the this quality of service, and quality of service of the intermediate node and starting node, that is the source node and destination node, and we finally find out the overall amount that we are getting. And here in this figure you can see that price charge in case of this cloud, that is our scheme, is initially it is high, but later on it is same as other schemes like DOPH, that is the dynamic pricing for sensor cloud, and there is a traditional one, and PTM, packet trade model. Whereas in the when the QAS is low, then we can see that this cloud is uh, charging less amount. So many papers also you can find for the pricing. Many directions are there for considering the pricing. You can explore this work. Then another concept, another along the same line, you can think of UAV virtualization. The same thing will happen with UAV. UAV you cannot purchase it, or rather, you can purchase it. Even if you are purchasing, you don't know how to fly it. Okay, for that, but you want to have the services. So for that, it is better to have the UAV services on rent. And from the service provider perspective, the UAV can be virtualized. The same UAV can be transmitted, this served for the multiple applications, for the multiple regions. So this is the basic figure of the UAV virtualization that we proposed. So you can see the same sort of architecture we are using. The virtualization is done, multiple UAVs are there, those UAVs are communicating, and finally the client or the end user, they are getting the services. Then whenever we are talking about UAV, if you send the data to the cloud, it may not be always very useful for time critical applications, right? For disaster management or something like that. For that, we uh, introduce a new concept, that is the fog enabled UAV as a service, in order to tackle the time critical application. So we in this figure you can see that we include over here a new layer which is known as fog layer. There will be some fog devices which can serve the which can be served as a intermediate layer between the cloud and physical UAVs, and that can serve immediately as per the request of the end user applications. So other possible, like with virtualization, you can work with the security, then access control, all of these things. Whatever virtualization we are saying, we can explore dynamic access point selection, dynamic data center selection, then open RAM based the sensors as a service and UAV as a service, then machine learning for handling VS formation, caching, pricing in UAVs also we can work on. Okay, anyways, this pricing I am already working on VS. I'm currently working on that. So this is all about, you can explore different thing, and you can discuss with me also. If you want to collaborate with me, you can send me an email. So other similar domain you will find the safety as a service. Okay, this is the virtualization of the decision. Okay, this work is particularly focused on the your transportation system. Okay, and similar thing is there, which is known as camera network as a service. On that also I work. If you will go through my Google Scholar profile, you will find different this sort of thing in my profile, and take it. So thank you. That's all from my side. If you have any question, just let me know.
Thank you, sir, for your valuable insight. So, if the participant do have any question, they may ask sir, and sir will reply.
Yeah, from participant, if you have any question, you can ask me now, or otherwise you can connect me over email also with your. You can say that I attended this FDP. I want to have this question, or if you want to collaborate also, that is also fine. So just let me know how I can be how I can be helpful for you.
Okay, sir. So then we can conclude, sir.
Yeah, sure.
Okay. Thank you, sir, for your such nice presentation and nice talk regarding the topic virtualization in IoT. So we will be concluding this session now, and we will meet for the second session of the third day, which we will be on at 12 noon today. And we will be joining with Dr. Iman Mukherjee. And we will share the link and we will notify you in the WhatsApp group when to join. Thank you very much.
Thank you all of you, all the participants and the organizers. Thanks a lot.